The structure we're looking at here is a pipe rack. It's very typical of the kind of thing that Multisteel would be used for in the oil, gas and process industries. What we're going to look at is how we convert this 3D model in AutoCAD, generated with Multisteel, into PDMS, how we can translate or transfer this model straight across to PDMS. If we look at the model a little bit more closely, let's just zoom in here. We can see that we've actually modelled all of the steel work, including the plates, haunches, stiffeners, and so on. Let's just shade it, get a better idea. See a bit more clearly now. We've also modelled this inspection platform with its cage ladder, hand railing, and so on. And we've actually added, although we can see the grating here, we've actually added a solid plate area so that we can send that across to PDMS, and obviously it will take part then in the clash detection side of PDMS, which is the whole objective really of sending the model through to PDMS in the first place. It's important before you send a model into PDMS that all of the steel actually has a unique name, or an item number as we call it in Multisteel. If I query a piece of steel in the drawing, let's take this column here, we can see that it's got a unique name. These are allocated either automatically in Multisteel, or they can be manually assigned to different groups of steel in the structure, but obviously the fastest way is to do it automatically and let Multisteel do it for you. So it has a unique name. That unique name will be carried across into PDMS, because when we do the clash detection in PDMS and we find a clash, it will report the name of the member that is causing the problem, and we need to be able to trace that back into Multisteel. So it's all part of the fully intelligent link that we have with PDMS, and the ability to track members, particularly in very large structures. It's important to realise too that Multisteel can be used to model other elements within a structure, not just the steelwork, particularly the foundations. In a moment we're going to have a look at adding the foundation elements, or just some hypothetical foundations for this structure. Elements can have openings, they can have holes or slots or any kind of cutout, and all of that information will also be sent across to PDMS. That's important because obviously it's critical to clash detection that holes are in the right place and any other slots for services are located correctly, because they may form a clash if they're in the wrong place and don't match the piping model. I've got PDMS running in the background on this machine, and I'm just going to flick across to it. This is PDMS, and at the moment all we have is a site. So under the world level of the PDMS database, all we have is a site so far. And what we'll see in the next video is how we can import the model very easily into PDMS and get a precise and exact fully intelligent model just by a single command effectively in PDMS.